Hi everyone, welcome back. Today we are looking at section 4.2 on implicit differentiation. It is not always possible for a relation to be written as an explicit function of one variable. Now that is what we are accustomed to. We are accustomed to having things written as explicit functions, meaning that the dependent variable is isolated and all of the other stuff is over on the other side. However, sometimes it's simply not possible to write it in that form. In those cases, in order to find dy dx, in other words, in order to find the derivative, implicit differentiation must be used. In this method, the derivative of each term in the relation is taken with respect to the independent variable x. This means that whenever a y variable is differentiated, it will always be followed by dy dx notation as a result of chain rule. The resulting equation for dy dx is then solved to get the desired derivative. So the process consists of 4 steps. Step 1, differentiate both sides of the equation with respect to x. Step 2, collect the terms containing dy dx all on one side of the equation, normally on the left. Step 3, factor out dy dx. That step is only necessary if there are multiple terms containing dy dx, so sometimes we can skip step 3. Step 4, solve for dy dx. So let's take a look at our first example. Find dy dx if y squared equals x. Okay, so we've got a nice, easy little function. We are going to differentiate both sides of the equation. So on the left, when we take the derivative of y squared, we get 2y. We need to follow that up with dy dx. On the right-hand side, we take the derivative of x and we get 1. Step 2 is to move all of the terms containing dy dx to the left. We already have that, so we don't need to do anything there. Step 3, if we have multiple terms containing dy dx, now would be the time to factor out dy dx. That is not the case here, so we can also skip that step. The 4th step is to isolate dy dx. So in this case, dy dx is being multiplied by 2y, therefore we need to divide by 2y in order to isolate dy dx. So the question asked us to find dy dx, and we did. It is 1 over 2y. Example 2. Find the slope of the circle x squared plus y squared equals 25 at the point 3, -4. So our equation is x squared plus y squared equals 25. This is a circle with center at the origin and a radius of 5. So step 1 is to differentiate both sides of the equation. So the derivative of x squared is 2x. The derivative of y squared is 2y. And when we take the derivative of the y term, we have to remember to follow it up with dy dx. On the right-hand side, the derivative of 25 is 0. Step 2, we want to isolate the term containing dy dx. So we want to subtract the term 2x. And now we want to isolate dy dx, so we will divide by 2y. So that is dy dx. In this question, we were given some extra information to work with. We were given the coordinates of a point. The x coordinate is 3 and the y coordinate is -4. So I will replace x with 3 and replace y with -4. And so that simplifies to give me 3/4. So if we were to draw a tangent at the point 3, -4 on the circle, the slope of the tangent would be +3/4. And example 3. Find the tangent and the normal to the ellipse x² - xy + y² = 7 at the point -1, 2. Okay, so our equation x² - xy + y² = 7. So we're going to differentiate both sides. The derivative of x² is 2x. The derivative of xy. Okay, we have two things being multiplied together here, so we're going to have to use the product law. So the derivative of the first times the second plus the first times the derivative of the second. And since we took the derivative of y in that step, we need to follow up with dy dx. Anytime you take the derivative of y, you have to follow up with dy dx. Next, we'll take the derivative of y², so that's 2y. And we follow that up with dy dx. And lastly, we take the derivative of 7, which is 0. So now let's get rid of those brackets. And then I'm going to move any terms that do not contain dy dx over to the right-hand side. And now I do have multiple terms containing dy dx, so I will factor out dy dx. And to isolate dy dx, I will get rid of 2y minus x by dividing by 2y minus x. Okay. In this question, we were given x and y coordinates of a point, so I can replace -1 in place of x and 2 in place of y. So I end up with 4/5 as the slope. The question is asking for us to find the tangent So the slope, 4 over 5, is equal to y minus my y value over x minus my x value. So there is the equation of the tangent. We were also asked for the equation of the normal. So the normal is perpendicular, therefore the slope is negative 5/4. That's equal to y minus the y value over x minus the x value. And so that's the equation of the normal. So we have both the tangent and the normal to the ellipse at the point -1, 2. That's it for today. Good luck with the practice questions.